Till now we have seen the examples in which we are finding out the eigenvalues but not the eigenvectors. But then there will be questions in which they will ask you even to find out the eigenvectors along with the eigenvalues. So the procedure is this. First step is you find out the eigenvalues and then take each eigenvalue, and using that eigenvalue you have to find out the eigenvectors which are corresponding to that particular eigenvalue, and you have to do it for every eigenvalue possible there. For example, if A is a 3 by 3 matrix, then we are going to get 3 eigenvalues, right? And if none of them are repeated, sometimes what happens is eigenvalues will be repeated, then you will be lucky. Otherwise, let us say A is a n by n matrix, then you are supposed to have n eigenvalues, and sometimes they will be repeated. If they are not repeated, you have to take all of these n eigenvalues one by one, and you are supposed to evaluate the eigenvectors corresponding to these eigenvalues. Okay, that is the procedure, that is the actual procedure. So what I will do is, I have taken a small example, and using this example I will explain you the entire procedure of finding out the eigenvectors. Once you find out the eigenvectors, then later I am going to go in a detailed manner for this example. Okay, later we can do it fast. So you might feel that it is going to take a lot of time to do this in exam, but then once you get used to this method, once you practice many questions, it will be very easy. It will not be that difficult at all. So what I'll do is, I have taken a small example, but then I am going in a very detailed manner here. Okay, it will take some time, but take this example. Later you need not follow all these steps. You can just skip these steps wherever you feel that they are not required, and you can directly jump onto the answer. Fine. See this. Let us say the question is, determine the eigenvalues and the eigenvectors of the matrix A equal to this one. So intentionally I have taken a small example, very small example. It is containing only 2 by 2 matrix, and we know that if the matrix is of size 2 by 2, then the number of eigenvalues is going to be 2, and after finding out the eigenvalues, we are going to take each eigenvalue and we are going to evaluate the eigenvectors for that one. Now see this one. First of all, we are supposed to find out characteristic equation of A. So what is characteristic equation? The determinant of A minus lambda, determinant of this matrix has to be equal to 0. That is characteristic equation. So take the matrix A and then you subtract lambda. Take the matrix A and then you subtract lambda from the principal diagonal elements. What are the principal diagonal elements here? 5 and 2, right? And then find out the determinant of it and equate it to 0. So if you just simplify it, then we are getting the equation lambda square minus 7 lambda plus 6 equal to 0. That is the characteristic equation we get. Now solve this characteristic equation and find out the values of lambda. Then we get two values of lambda. One value is 6 and other value is 1. Now what did you understand from this? It means that this particular matrix is having two eigenvalues. One is 6 and other is 1. Next step is, we are supposed to find out the eigenvectors. How can we find it out? Take the eigenvalue, right? And then for that particular eigenvalue, we are supposed to find out the eigenvector. So see the procedure. So what is eigenvector? So where did everything come from? So if you remember, initially we are discussing about this Ax equal to lambda x. This is where this x is, right? This eigenvector is, and we wanted to find out the value of this x, isn't it? So now since we got to some point where we found out the value of lambda, you can substitute the value of lambda and you can substitute the value of A and you can find out the value of x. Got it? So what is that I am trying to do? We know the value of A and we found out the values of lambda. Now you take one of the value of lambda and substitute here. Therefore, for that corresponding value of lambda, you can find out the value of x. That x is nothing but the eigenvector. Got it? So now Ax equal to lambda x can also be written as, you can bring it this side. It can also be written as A minus lambda I into x equal to 0, isn't it? Therefore, A minus lambda I into x equal to 0. You can write this equation, and now you can substitute A there and you can substitute lambda there and you can find out the value of x. And in this case, since it is a 2 by 2 matrix, what will be the size of the matrix, this vector x? It will be a 2 by 1 vector, isn't it? Why? Because for n by n matrix, the vector size will be n by 1, the eigenvector. Therefore, we are assuming that let capital X equal to x1, x2, these two be the eigenvector. If this is the eigenvector and if this is A, where is A? A is here, and lambda is 6. I am assuming that lambda is 6 initially. If lambda is 6, then I am substituting everything in this equation. Why? Because they all should satisfy this equation. See this. So if this is the eigenvector, then the equation should be satisfied. What is the equation? A minus lambda I into x equal to 0. Therefore, I am substituting everything here. A minus lambda I into x equal to 0. 0 is nothing but a null vector here. Fine. Now if you observe this is in the form of Ax equal to 0 form, which is nothing but set of linear equations, linear homogeneous equations. If you remember, Ax equal to 0. Got it? Therefore, I am just applying the row transformations to simplify the quotient matrix in order to get the answer quickly. So only row transformations are supposed to be applied. See, this thing I am not doing anything new here. Till here it must be new to you, but from here on solving the equations is nothing but the old concept. We have already seen it, right? So I am just using that. What is it? This is the quotient matrix, this is the variables or unknowns we have, and right hand side is simply zeros. It is nothing but set of linear homogeneous equations, right? So I am solving the set of linear homogeneous equations. How many unknowns are there? 2 unknowns are there, and as of now we are seeing that there are 2 equations, but then after applying these transformations, one equation got completely vanished, isn't it? So, or if you want to analyze it in another way, we know that we have to find out the rank of the quotient matrix. So what is the rank of the quotient matrix here? After transformations, you can clearly see that the rank of the quotient matrix cannot be 2, because the determinant of a 2 by 2 matrix is going to be 0. Therefore, the rank of the quotient matrix can be, in this case, be 1. So rank of this quotient matrix is 1. And how many unknowns are there? 2 unknowns. Rank of the quotient matrix equal to 1. Let's call it as R. And the number of unknowns, let's call it as n, equal to 2. And we know this already. This is nothing new. You already know that. I am just revising it. So n minus r is nothing but 2 minus 1, which is 1, which is greater than 0. So whenever we have n minus r greater than 0, in case of linear homogeneous equations, we know that there will be infinite number of solutions, right? Or how many linearly independent solutions will be there? One linearly independent equation solution will be there, and from that linearly independent solution we can form many solutions. Therefore, the number of solutions are going to be infinite. So what does it mean? For this particular value lambda equal to 6, for this particular eigenvalue, we are going to get lots of eigenvectors. Now let's see what are all the eigenvectors possible here. Now how to solve it then? Whenever you have n minus r greater than 0, we know that we have to substitute some random value in those many unknowns and then evaluate the remaining random values in terms of these unknowns, right? So what are the unknowns? How many unknowns should I substitute the random value? 1. Random value means initially give some value and you evaluate the other values in terms of this. Therefore, let me choose x2 equal to k, isn't it? So this is all the theory. Therefore, infinite number of solutions are possible, and n minus r equal to 1 unknown, which means n minus r unknowns. Okay, here in this case n minus r happen to be 1. Therefore, one unknown will be given some value and the others will be evaluated accordingly. Some value means some initial value. So I am assuming that, let me give x2 equal to k. So from this one we clearly see that we get the equation, only one equation we get. What is the equation? Minus x1 plus 4x2 equal to 0. Minus x1 plus 4x2 equal to 0. Now in this equation, if you substitute x equal to k, x2 equal to k, then we get x1 equal to 4x1. So what did we get? x1 x2 is equal to 4k is x1 and x2 is k. Now you can pull out k, then what will be remaining? 4, 1, right? Therefore, this is the eigenvector we got, In fact, it is not a single eigenvector. You can give any value to k and you can observe that you will get a different eigenvector. Therefore, there are infinite number of eigenvectors for this particular eigenvalue 6. Right? So this is, we have solved it only halfway. So it might look very big, but then since I am writing everything and explaining you, it is looking big. But once you do it on yourself, it will not be that big. So what I mean to say is, for lambda equal to 6, for one of the eigenvalue, we got the eigenvector as this one. How many? Infinite number of eigenvectors, right? Now let's find out how many eigenvectors are possible for lambda 2 equal to 1. Okay. We have seen the corresponding eigenvectors for the eigenvalue lambda equal to 6. Now we shall see the corresponding eigenvectors for the eigenvalue lambda equal to 1. So how to do this? Same way. A minus lambda I into x equal to 0. Write that equation and substitute in place of A the given matrix A, and in place of lambda we have to substitute the corresponding value of the eigenvalue for which we want to find out the eigenvectors. Earlier we have found out the eigenvectors for lambda equal to 6. Now the other one remaining is lambda equal to 1. Therefore in place of lambda you substitute lambda equal to 1. Okay. Therefore in place of lambda I am just substituting lambda equal to 1 here, right, and then I get a minus I into x equal to 0. So that is why I am going to get 5 minus 1 here, 2 minus 1, which means from here I am subtracting lambda I and lambda I here. Okay, and into x. So same, I am just assuming that x equal to x1 x2 be the eigenvector. Then now just say this, it is in the form of a x equal to 0. So which is nothing but set of linear homogeneous equations, isn't it? Set of linear homogeneous equations. So how many equations we have? 2 equations. It looks like we have 2 equations, but then do we really have 2 equations there? That we can find out after finding out the rank of the quotient matrix A. So before going ahead and finding out the rank, I want to apply some transformations because it is looking very simple, right? And by intuition you can see that one of the row can be made 0. So I am intentionally making the second row as 0. So what did I do? R2 is replaced with R2 minus R1 by 4, which means you divide this one with 4 and then subtract it from R2. Then I am going to get 0 here and 0 here, x1 x2, right? Now the number of unknowns equal to 2, so n equal to 2, and the rank of this matrix is 1. Therefore the rank of this matrix, quotient matrix, is 1, and n minus r, we got a number which is greater than 0. So whenever n minus r is greater than 0, in case of linear homogeneous equations, we know that there will be infinite number of solutions. Therefore for this equation, for this lambda equal to 1, we now know that there will be infinite number of eigenvectors. Now what are all they? You can find out only after solving for x. Okay, how can I solve for x? Now n minus r equal to 1, which means for one unknown we are supposed to give some initial random value, and using that value we are supposed to evaluate the other values, right? Therefore let me assume x2 equal to k. So if I assume x2 equal to k and find out the equations available here, so from this matrix, from this equation Ax equal to 0, what are the equations that are available? 4 into x1 plus 4 into x2 equal to 0. 4 into x1 plus 4 into x2 equal to 0. Divide RHS at LHS by 4. Then we are going to get x1 plus x2 equal to 0, which is nothing but x1 equal to minus x2. We already have fixed x2 as k. Therefore x1 equal to minus k, right? So the eigenvector corresponding to the eigenvalue lambda equal to 1 is nothing but x1 x2, which is minus k and k. So if you pull out k as common, we get minus 1 and 1. So these are the set of eigenvectors. Why am I saying it as a set? Because it is not a single eigenvector. For every value of k, you will get a different eigenvector. There will be infinite number of eigenvectors. Therefore, for the eigenvalue lambda equal to 1, the set of eigenvectors we get is this one. Earlier we have already seen that. Similarly we got set of eigenvectors for lambda equal to 6. So from this example you should know or learn how to find out the eigenvectors. What is the procedure? Find out the eigenvalues. After finding out the eigenvalues, you take each eigenvalue and then for that particular eigenvalue you find out the corresponding eigenvectors, and in case if it is 2 by 2 you are going to get 2 eigenvalues, and therefore you have to evaluate 2 cases. In case if A is 3 by 3 matrix, we are going to get 3 eigenvalues, and we are going to evaluate eigenvectors for each of these 3 eigenvalues. In case if it is n by n matrix, you will be getting n eigenvalues, and for each one of them you have to evaluate the eigenvectors. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.